The Parramatta Engineering Innovation Hub aims to foster collaboration and innovation, but its amphitheatre falls short. Positioned above a busy workshop and exposed to constant foot traffic, the space is noisy, visually distracting, and lacks the focus needed for effective learning. The staircase cutting through its centre adds to the disruption, making lectures difficult to follow. Instead of seeing this as a design flaw, we see an opportunity. By installing transparent acoustic barriers and implementing simple scheduling policies to reduce traffic during key sessions, the space can be transformed. These low-cost changes would greatly improve focus and learning without requiring major renovations.
The Parramatta Engineering Innovation Hub Amphitheatre is located in a loud and distracting area that disrupts users during lectures. To guide this process, we identified several key questions that must be addressed. How does the placement of the amphitheatre above the workshop contribute to the noise distraction during lectures? In what ways does the central staircase running through the amphitheatre affect the flow of the space during lectures? Lectures. What role can transparent acoustic barriers or partitions play in reducing disturbance caused by surrounding activities, and what policies or schedule changes could be implemented to minimize disruption from foot traffic and workshop activity during lectures? These questions will guide our research and inform the development of our case, aiming to improve the functions and overall learning environment of the amphitheatre.
We began our research on mapping out all the contributing factors to the issue using Miro. This visual approach helped us revisit the collective problems we explored in Assessment 1 and led us to identify a major gap in our earlier work, specifically a lack in depth research on how the problem affected students directly. Through reflection, we decided to reassess our findings through a fresh perspective. This led us to more focused design issues, the amphitheatre. We broke it down into smaller, more specific concerns, mainly how it's designed and the environment's impact on students' learning experiences. Using Miro again, we generated a new map, this time focused on solutions. This process led us to craft a final problem statement and 4 subsidiary questions that gave our research clear direction, particularly towards finding a low cost and practical improvements. Next, we conducted field research, photographing, measuring dimensions, sketching ideas, and running a student survey. These activities helped us evaluate our concepts visually and functionally, grounding our ideas in real-world context. Based on our findings, we concluded that installing transparent acoustic barriers around the amphitheatre's edge would significantly improve the space. We finalized this solution by confirming measurements and infrastructure feasibility, ensuring it was both effective and realistically implementable.
Distractions during lectures is a significant issue in our learning spaces. Using Miro mapping, we narrowed this broad concern down to specific, manageable factors. This helped us focus on the amphitheatre area as a key source of disruption. We conducted site measurements, sketches, and a student survey to understand the issue more deeply. The results were clear. 100% of students surveyed agreed that the physical barrier separating the amphitheatre would help improve their focus during lectures. Based on our findings, we proposed installing transparent acoustic barriers made of durable glass or acrylic. These will be mounted using brackets on the outer side of the existing metal rails and extend upwards by about 12 meters, dampening sound while maintaining visibility. Alongside this physical solution, we suggest new regulations, limiting workshop activity during lectures and restricting access to the central staircase. These actions would help reduce both noise and visual distractions. Together, these changes form a practical, cost-effective approach to improving the learning environment. They reduce distractions, promote student focus, and enhance the lecture experience, without requiring major renovations.
Student learning at the Parramatta Engineering Innovation Hub is clearly affected by the amphitheatre's poor layout. Constant noise, foot traffic, and visual distractions from the adjacent workshop and central staircase make it hard for students to focus during lectures. To address this, we propose installing transparent acoustic barriers, enforcing basic guidelines, like limiting workshop activity during lectures and reducing access to the stairway at key times. These changes are both affordable and practical to implement. These adjustments would create a more focused and supportive learning environment. Not only would they minimise current disruptions, but they would also help shape a more organised and effective educational space for the future cohorts. However, for the successful implementation, further research is essential. We must explore factors such as total costs, potential disruptions during construction, the effectiveness of barriers, and sourcing options. Overall, this added research will help us refine the idea, reduce the risk, and ensure that all students and staff benefit from the changes. With thoughtful planning, we transform a flawed space into a powerful tool for learning and collaboration in Western Sydney.